All right. So I said that FT, you have FT, cosine 85, puts it in the x direction. RA is always a minus, and so minus RA times what? Cosine
75.
You could say either way. You could say cosine 75, or you could say cosine negative 15. It's still going to give you the same answer. Negative 15, yeah. Because you're saying, obviously a minus. And then that equals MAX. Okay, now you do it for the y direction. Remote control. What? Okay, now we'll do the y direction.
Is mg one of the forces that get subtracted?
It's in the y, right?
Yeah.
Anything down we'll call negative. Anything up positive. So now we have the force of thrust times sine 85 minus RA cosine 75.
Why is it still cosine?
Oh, sorry. Way off. We'll edit that out. Sine 75 minus what? Mg, and you get all that one, equals MAY. Because you have a, now your acceleration's got an x component and a y component. So we're not putting numbers in yet, but this will get pretty complicated. Yep.
Are you going to care if we take the complementary angle or not?
I don't care as long as you get the same answer. I always, try and I want the acute. I want it to be the acute angle. I don't want it to be greater than 90. I don't want any obtuse angles in there. So, but anything as long as it's acute, it's fine. Just watch your sign. Make sure you don't. The sign all of a sudden it switches to negative and positive and all that. Okay. So now let's look at number 8. Is there a normal force?
No.
And why wouldn't there be? I think, someone said, well, there's always a normal force. Why isn't there a normal force here?
Because there's nothing keeping gravity from doing work on it aside from...
So normal force is a contact force. You have to have two solid bodies.
Exactly.
So there's not two solid bodies here. So there's no normal force. But so it's a force of lift, I guess, it's holding it up. And it says it's moving at 75 degrees of horizontal. Okay. So Andrews has his up here. And now you do need to put angles, and I'll show you why.
My direction motion's almost exactly 75.
So, okay, so the way I show, and a lot of you put the big arrows, which I've taught you to do. And you can do it that way still, but whenever it gives you a specific direction of motion, I make a dotted line and I just do that. And you can make a big arrow at that point, but then you have to show the degrees, so 75 degrees. Okay, now that's for direction of motion. Now let's write out what all we have here. We have a force of thrust. We have, what's the most obvious one?
Force of
mg. We have to have gravity, of course. So we're going to have mg, and I don't know how much it weighs, but if I make my mg, all my other lengths are going to have to be relative to that, if that's what I arbitrarily call the weight of the rocket. And then some of you have force of lift. They've been putting force of lift on throughout the day. Now a rocket looking like this, I'm thinking of a rocket like this, not like a cruise missile or something with the wings pop out. If there's no wings, these are fins, right? Give it stability, perhaps cause it to corkscrew. But these don't give it lift. To be lift, it has to be like an airfoil. Okay, there's an airfoil up there, and you have to have that kind of airfoil wing type thing for whenever you're going to put lift in, a significant lift. So we don't really put lift on rockets. All right, so that's not going to be there. There's no wind. It didn't say there's wind, so no force of wind. We do have force of thrust, and we do have air drag. Now this is wrong. What I'm going to do is wrong. It seems okay, it seems smart, but doing it wrong.
That's not good.
If you call that your force of thrust, that can't be right. That's impossible.
Well,
why would that be impossible?
it's going backwards, isn't it?
No, that wouldn't go backwards, but...
The thrust is moving in the x and y direction.
True.
To counterbalance the different forces.
Yeah, so thrust, I mean, I agree, the thrust is going to be at an angle, but why can't it be at 75?
Opposite gravity.
because you have gravity, because it has weight. And remember, the vectors must add up to give you a resultant vector in the direction of motion. So head to tail, when I slide, if this were the case, and I slid mg up here, remember we did this way back in like October, if I repeat mg up there, then I'm going to get a resultant like that. That's not at 75 degrees. You see?
You're right.
So now, as far there is air drag, and depending, there's not a whole lot of air drag on a rocket except that it's going at high velocity. And so RA, the formula for RA, and I put this up for some classes before, RA is 1/2 d rho a v squared. Well, that v, the A is small. A is the profile area of what's coming at
What's
you.
that? What's rho?
Well, rho is the density of the air, the medium it's going through. D is a drag coefficient. We'll go on to those more later. A is a profile area. So if this thing were coming at me, the last thing I would see is a circle. And so that would be the profile area of this, not surface area, profile area. But V is the velocity, and velocity is squared. So rockets move at a very high velocity. So you get a significant amount of air drag because of the high velocity, even though profile area is small. So we would have an RA that's fairly large, depending on whether it's an Estes rocket or a big Saturn V, like up there. So your RA will always oppose motion. So RA is back. It's always going to be back of opposite direction of motion. So if I make that my RA, then I've got to adjust my thrust. Okay. So the thrust has to be. Give me a possible angle.
Has to be
Greater than
87, 85, 80, depending how big it is, right? How long it is. But if it's 85, like that, well, 85, so almost 90. So it's 85. It's up like that, and say it's that big. That's my force of thrust. Then, when I add my mg to that, I slide it up. Looks like that thrust was too big. Something like maybe like that. Because I want to add my mg vector to it and get my direction of motion out. That direction of motion right there, when I slide that up. So you're visualizing this. And then the RA just gets added on at the end. RA cannot be such that it ends up making it go backwards. So when I add my mg, it'll come to about there. I add my RA to that. I'm still going to get acceleration. This is going through some pretty thick air. I'm still going to get acceleration at 75 degrees. So now you see why we need a video rather than a drawing. I can't explain this on the internet with a drawing. So I've got to be able to actually talk through it. Now it's getting complicated. So anyway, that would be what you're drawing, just those three forces. Okay, so we got it right here. And the last thing we got to do before we go on to the next one is to do the equations. And so now we've got an x equation and a y equation. So you draw, let's assume that's 85 degrees or whatever. It could be 87 or whatever, but it's better, higher than 75. You now write the equation for the x and write the equation for the y. I'll give you a second to do that. Just pause.
Let's pause and just push that button again.